Hello friends, we will continue with force and laws of motion. Okay, in this lecture, we are going to see the conservation of momentum. Okay, in the last lecture, we see the third law of motion, that is Newton's third law of motion. Okay, you know that. Okay, the Newton's first law of motion, second law of motion, third law of. Now you will be very much familiar with it. Correct? Okay. Now, so let us go to the conservation of momentum. Now here the question is about the conservation. Now what is conservation? It is, we can say, something which is observed. That is not changed. Like that, the meaning of conservation is. Sorry. Okay, now the momentum. What actually the momentum is? Momentum, you know that it is the product of mass and velocity. So the momentum is conserved. That is what it is telling about. That is, momentum is not changed. Okay, what actually here the setup is. Okay, now in this case the setup is that, okay, there is two balls. You know that if the marbles, okay, now suppose you may even played the marble, okay, then you may see that, okay, when we are throwing a marble to another, okay, the marble will move from there, correct? Okay, and which marble we are used to throw on it, that either its velocity is decreased or it is stopped, correct? Okay, so here now the two marbles are there, that is of MA and MB, that is A and B are the two marbles, we can say. MA is the mass of the first marble and MB be the mass of the second marble. Understand? MA is the mass of the first marble and MB be the mass of the second marble. Okay, so here we can say, okay, now here we can say that what we can say here, the so MA is the mass of the first marble, MB be the mass of the first marble. Now both these marbles are moving in the same direction. Where it is moving? It is moving in the same direction. Now, okay, this MA having the mass, MA having, okay, a velocity that is of initial velocity, that is of UA. Understand? Okay, then we can say that and the marble MB having a velocity that is of initial velocity, okay, UB. That is, okay, both the marbles are moving one after another. Okay, one is there and behind that the other is moving like this. Now if this UA, that is initial velocity of the marble A, is greater than the initial velocity of the marble B, is very important. That is, which is moving faster. Okay, the marble A is moving faster and the marble B is moving little slower as compared to the marble A. So obvious, we can say that after time t it will collide each other. After time t, correct? Okay, it will collide each other. Sure. Okay, so when it is collide, okay, here one force is applied. A is applying a force on B, correct? Okay, that is of we can say that F, force applied by A on B, correct? Okay, then we can say that now by the Newton's third law of motion, okay, the B is applying a force on A, correct? Now when it is equal in magnitude but opposite in direction. Understand? Okay, so now in this case, okay, from here one thing you can say that is of FAB is equal to minus FBA. Why it is so? Because okay, this sign shows that okay, this okay in opposite direction. Okay, this sign means it is in the opposite direction. Understand? Okay, that only it is of showing, nothing else. Understand? Shine. So FAB is equal to FBA. Now after the collision, now the collision is over. Okay, after this collision, okay, this body is again started to move in the same direction. Understand? Now obvious, you must have to understand here that after collision, sure, the velocity of the bodies will be changed. Obvious? Okay, that we can assume that the body, that is MB, will start to move little faster than the earlier. Okay, and MA will be slow down, little slow down at all, because it is some energy is passed to the body B, that is the marble B. Okay, so here the VA and VB be the okay velocity after collision. Okay, that is VA is the velocity of the okay mass MA after collision, VB be the velocity of the marble B after collision. Okay, understand this much? Okay, so this is the setup. Understand? Two marbles are moving on the same direction. Okay, one is of marble A and the other is of marble B. Sure, both of them have the mass of MA and MB respectively. Now, okay, marble A is having velocity, that is initial velocity UA, and marble B having the initial velocity UB. Okay, now UA is moving faster than UB, that is the velocity of the marble A is more than that of the marble B, so that marble A collide with the marble B, okay, for a time t. Sure. So due to this, okay, the marble A apply a force on the marble B. Okay, now by Newton's third law of motion, marble B apply an equal and opposite force on marble A. So it can be represented as okay, FAB is equal to minus FBA. Sure. Okay, that is the negative sign shows that okay the force is in opposite direction. Sure. Now after collision, okay, the marble A will move with a velocity UVA. Obvious, it will be little less than that of the earlier. Okay, and marble B will move with a velocity VB. Sure, all of you? That is after collision. So here the two thing is there. That is the three concept. One is of before collision, one is of the time of collision, and the other is of after collision. Understand? Now from here, now you are having VA and UB. Now we can say that here, what we can say? We can say here FAB, that is the force applied by A on B. Now what is the force is? You know that is of force is equal to MA, correct? Okay, now what is the force here? We can say it is of MA. MA means it is the mass of the body A into VA okay, minus ua upon t, correct? That is the acceleration. Getting? Okay, that is the FAB. Now what is F? Okay, BA. FBA means, okay, again the formula is remain MA only. That is, here it is of MB into VB minus UB upon T. Correct? Sure, all of you? Now you know that we see that FAB is equal to minus of FBA. Correct? So in the place of FAB, what we are going to write is MA into VA minus UA upon T. Correct? Is equal to minus, because sign opposite in direction. Okay, MB into VB minus UB, okay, upon T. Correct? Multiplying T on both the sides, so TT will cancel. Okay, now MA is multiplying inside, so MA VA, okay, minus MA UA, okay, is equal to minus MB VB plus, okay, because minus into minus, here these two minus into minus plus, okay, plus MB, okay, VB. Sure, all of you? Now this minus we are going to take to this side, and this we are going to take to that side, so that it is of MAVA E plus MBVB, okay, is equal to, okay, MBVB, okay, plus okay, MA, sorry, here it is a U, it is. Here it is U. Correct. Here it is of UB. Okay. So that here it is taken to this. Here it is of MA. Okay. U. Here also it is. Here mistake. It is MA, it is of what it is? Already UB it is. MB UB, okay, plus MA, this is of here, that is of UA. Understand? So now what is here? Now from here, one thing you can understand, that is, look here, look, this MAUA plus MAUB is the total momentum. Okay, what it is? Now it is initial, that is before collision. Okay, now MAVA plus MBVB is the total momentum after collision. So you understand that? So here we can say that the total momentum before collision is equal to the total momentum after collision. That means the total momentum of the two balls, okay, remain unchanged. That is remain same. No, unchanged means conserved, saved, not changed. Understand? That is conserved. Okay, so this is called the Newton's, conservation of momentum, law of conservation of momentum. Okay, how can we define it? The total momentum, okay, before collision is equal to total momentum after collision. Getting all of you? Okay, that is, the momentum is not changed. Okay, it is unchanged. Okay, so here the definition is, okay, what is the definition here? The sum of the momenta means the plural of momentum is momenta. Understand? That is, what is the sum of the momenta? That is initial, while telling about before collision. Okay, before collision means it is of MAUA plus, okay, MBUB. This is the total momenta, okay, sum of momenta of two objects, okay, before collision, okay, is equal to the sum of momenta after collision. After collision means it is of MAVA plus MBVB. Understand? Okay, that much only. Okay, so one more thing, it is especially provided that no external, okay, look here, no external unbalanced force acting on them. Now we know that when these two balls or marbles are collided with each other, okay, now the force exerted on B must be just because of the motion of the ball A. Okay, there from external some source must not be applied on it, force or must not be applied. This is a condition here. Okay, otherwise we can't tell, okay, it happens like this. Sure, all of you? Okay, so this is the law of conservation of momenta. So what is there? The sum of momenta of two objects before collision is equal to the sum of momenta after the collision, okay, provided that there is no external unbalanced force acting on them. Understand, all of you? Okay, external means suppose, okay, it can be a wind or it can be some other force, must not have to exert on it. The marble B must be exerted by the force of marble A only. Okay, no other force, okay, must not exert at this time. This is called the law of conservation of momentum. Sure, I hope you understand it well. Fine. Okay, so you must know, actually we concluded, okay, this lesson here. Next lesson we will see the sums of this lesson. Okay, how to do the sums. Okay, so what you have to do, you have to do study all the formulae. Okay, we studied, that is a force equation we studied, law of conservation of momentum we studied, okay, that is momentum, formula of the momentum we studied. Okay, all that, okay, you have to study. Understand, these are the three main formulae, okay, that is of a momentum, that is P is equal to mv, okay, and the other is of a force equation, F is equal to ma, and now the, okay, conservation of momentum, that is of MAUA plus MBUB is equal to MAVA plus MBVB. Sure, so that we, using these formulae, okay, what we can do, we can do the sums. Okay, so that is very important. Sure. Okay, so please read the textbook thoroughly. Please read the textbook thoroughly and study all the formula, so the next class you will be able to do the sums properly. Sure. Okay, for today it's enough. Bye, have a nice day.